So, as I said, we're going to integrate two things again here. This time axiomatic and analogical reasoning. And so let's start talking about analogies a little bit. So here are some examples. Pawn is to hand as soul is to foot. That's the old classic one by Aristotle. And then an atom is like a solar system by Rutherford. It's a bit flawed, that one, but that's his idea. 3 is to 6 as 2 is to 4. John is like a gorilla. It says something about John, right? If you know what a gorilla is. Then you can think about those properties and see which ones apply to John. A basset is like a beagle with short legs. And an electric battery is like a reservoir. So here's a quote. When people hear an analogy such as an electric battery is like a reservoir, how do they derive its meaning? We might suppose that they simply apply their knowledge about reservoirs to batteries, and that the greater the match, the better the analogy. Okay, and here's a quote by Douglas Hofstadter. It is tempting to think that analogies are between things in the external world. Things in the external world. But I really want to say that analogies happen inside your head. They are connections between things inside your head. We're going to formalize that shortly. And he goes so far as to say that analogy is the core of recognition, even. But in any case, it's clear that analogies are ubiquitous in human cognition, for example, in learning, reasoning, and creativity. It plays a central role in mathematics, for example, in algebra and category theory. And it has been studied in philosophy since antiquity, also this one. So there are at least, I suppose, 3 kinds of symbolic reasoning. Inductive reasoning, axiomatic reasoning, analogical reasoning. And usually we have different systems for doing these 3 things, but we want to see if they can be integrated. So we can do that, people can do that, we can easily integrate all those types of reasoning. So for example, we can reason inside a certain domain, and then we can use an analogy to jump to another domain and reason a little bit there. Now we can use another analogy to jump back, for example, to the original domain, or to another domain, and end up with a conclusion. So we have a system that we call ALICE, which can do inductive and axiomatic reasoning, but not analogical reasoning. So we wanted to add analogical reasoning to that system. So now I'll describe that system to you. So first, it's a bit technical. First of all, the syntax is from first-order logic with language, or vocabulary, term, atomic formula, yes, and yeah, so that's as usual. And then our notion of formula is very restricted, however. So we just say that a formula is defined like this. It's an atom or a negated atom, basically. So now, how do we describe a domain in this setting? Well, a domain is just a set of variable-free formulas. And it has to be consistent, the domain, in the sense that not both A and not A can be elements of the domain. And this notion generalizes the notion of domain, of a model that is used in model theory. So it's sufficiently strong for many purposes. So here's an example of a domain. 2 plus 2 is 4, 0 is not 1, and so on. Here's another one from a farm. Sheep, a lamb, father, and so on. And then, given a few domains, we can define an observation stream, and that's what that models what an agent who walks around in an unknown world might perceive. So a mix of different things, like some arithmetic, some from a certain graph, some facts of logic, some facts about that farm, some facts about astronomy, and so on. And I have to make start building theories about that. And who is building the theories, and who is the agent here? It's going to be a developing agent who will develop its belief sets gradually. And a belief here is just an arbitrary formula. So here are some beliefs. They can contain variables as well, like x times 0 equals 0, for example. So that reflects a universally quantified belief. Beliefs may be true or false, of course, about a certain domain. And what we also need here is a rewrite rule, and that's just a pair of terms, and you're supposed to be able to replace one with the other without altering the truth values. And then finally we have the notion of analogy, and that's just a partial function that will map the language of one domain on the language to the language of another domain. And arities are preserved both by function symbols and relation symbols. So in this way we can easily render Aristotle's analogy, for example, by mapping hand to foot and pawn to sole. Then the relation under will be preserved. And the same thing with Rutherford's analogy. We map sun to nucleus and planet to electron and so on, then it works. Okay, so now that we've defined these things, we can define a knowledge base. And a knowledge base is a set of beliefs for each domain, and a set of rewrite rules for each domain, and also an analogy for each pair of domains. And remember that analogies are partial functions, so they can be empty. If we don't see any similarities, then we can have empty analogies. So now with a knowledge base like that, we can start drawing conclusions and doing proofs that not only go through inside a certain domain, but that also goes out and then in again. So here's an example. If you want to prove that the top statement there, that A belongs to the domain DI, then we can first use a rewrite rule to arrive at a different formula. Then we can use an analogy to move to a different domain. And then we can continue reasoning in that domain, and eventually we might reach something that we believe in, something that we hold to be true. So in this sense, we can actually reason in the ordinary way. This is like an ordinary proof, but with the additional possibility of leaving one domain and going into another, and then, so on. Okay, and then a developing agent here consists of a knowledge base of this kind, and then a function that updates the knowledge base in response to the observations. And again, we have resource bounds on the computation, width, length, and the size of the knowledge base. Okay, so we developed this a prototype of an extension of Alice that we call Alice Plus. And it receives streams of observations from multiple symbolic domains. It integrates inductive, axiomatic, and analogical reasoning. And this program, it's also just a prototype, and it can be extended in many directions. You can look at the code and at some examples for that one as well. Okay, thanks.